Hello, all. Happy Tuesday. Hope you had a great weekend. Last week we spent the whole week in lesson 3, which was really starting to get used to these quartics and quintics and all their different characteristics, maximums, minimums, increasing, decreasing, and so forth. Today we're going to look even more into these quartics and quintics, and really starting with cubics and building up and really looking at the functions that can build them. So how their factors work more specifically today. So this video will set you up for all of lesson 4. It is not as long as lesson 3, luckily. And then there'll be a Google form at the end of it. And then after this lesson, it's really kind of a turning point for the last 2 lessons of this chapter. This was the bulk of the really big content. So Thursday will really kind of be a catch-up day to review all of these items that we've done so far in these couple weeks. So just as a heads up. No, but today our goal is lesson 4, which is looking at the factors that can build cubic, quartics, and a little bit of quintics. So you'll see we're trying to connect our graph behavior to the factors. We're constructing cubics and quartics using these factors and seeing how many real and imaginary zeros they can have. So if you remember from the end of lesson 3, we talked about all the possibility of zeros for these functions. So we're going to look a little bit closer at it today. So first off, we're looking at page 249 for the function construction lesson. In this first getting started, I'm going to do this with you, and this is just a reminder of how the zeros work. So we've talked about this in December with how the zeros play in, but just a reminder. So it says sketch some functions that have these zeros that are cubic. So, and there's a lot in this lesson that talks about compare with your classmates, similarities, differences. Obviously, we're not sitting in a classroom right now for you to compare, so that part won't really apply as much today. It's more about coming up with the functions, coming up with these explanations. So remember, when we're given the zeros, so first of all, on the graph, that means the graph is going to cross at those points, so 2, -5. And then remember, in the factors, so if we're trying to create the function, it's always the opposite in the factors. So like if I have a 0 of 0, well, that just means that we have a factor of plain x, technically x minus 0. If I have a 0 of 2, that means I have a factor of x minus 2. And if I have that 0 of -5, that means I have a factor of x plus 5. So given the zeros in this form, those go on the graph as is. But when you write the factors, that's when you have to flip the sign, because it comes from when we set this function equal to 0. So if we wrote that graph, and then if we were to draw it, it would go up through, down, and back up. So since each of those are unique, or another word you might hear is distinct zeros, that means the graph crosses through once and keeps going, and then it'll have its turning point. Now, there's this Desmos link here because technically there's an infinite amount of answers we could have, and this just lets you play with it a little more. So like this is the one I just did, and that's what the Desmos link will take you to. But notice I could put a 2 in front of that. I still have the same zeros, so that is still a valid function, but it's a little bit skinnier than it was. I could put a negative in front of it. Still the same function, but the end behavior just changed because I changed that a value. I could put a 1/2 in front of it. It gets a little shorter. What if I did 1/10? That got way shorter. Notice, still the same zeros. I could put a negative in front of that one. Flipped. Still the same 3 zeros. So that's just the idea that a value can change, so the end behavior can change, how skinny it is, the stretch compression can change, as long as you have those factors in there. That's what creates the graph. So reminder that the factor gives you the 0. And now the second one is a reminder of this multiplicity 2 piece. Also keep in mind these are cubics. So when we have a cubic, that means you have to have at least 3 x terms. When you multiply it all out, it needs to turn into x cubed. So like if I were to multiply this, x times x times x. Oh, I'm moving things around. Switch my marker. X times x times x, that would turn into x cubed, which is what makes it x cubic. So like this next one, I'm only given 2 zeros, -3 and 4. So -3 and 4. But there has to be 3 x's in the factors. So I know I have the factor of x plus 3 and x minus 4. This key thing here, that multiplicity 2, means that there's 2 factors of x minus 4. So I also, forgot that parenthesis. I could also write that as x plus 3, x minus 4, and then x minus 4 a second time. So that's how we get that cubic. You have 3 of those factors. On the graph, what that looks like, the x plus 3 is one distinct factor, so that means the graph goes up through it. The x minus 4 has a multiplicity of 2, so that means it bounces off the 4 and then keeps going. So when you have a multiplicity 2, that's when you get that bounce piece in there. Okay, so today what you guys will be doing is exploring, playing with this through building cubic functions of these given functions. So that's that getting started piece. You can skip a page starting at activity 4.1, which is on page 252. You are given 8 different functions. Our goal is to multiply them together to create cubics. So right now these are all linear and quadratic functions. Remember, linear means a degree of 1, so that's just x to the first power. Barely looks like a 1 there. But anytime you have something to the first power, you really don't have to write the power, it's just x. So my linear factors would be this one. All of these are linear, whereas quadratic means we have an x squared. So all of these are quadratic. Now you might be saying w of x doesn't have a square anywhere in it, but it has 2 x terms, so it has x minus 1 and x plus 1 with that negative out there. So if I were to multiply that out, meaning like if I were to use my box method and I were to multiply that out, notice this top left gives me an x squared term. So it would turn into x squared plus x minus x cancels out, minus 1. So that is a quadratic because if I multiply it, we get that term out front. And we know the zeros of these graphs, like this first one would have a 0 of just 0, because it's just an x term. X plus 1 has a 0 of negative 1. X minus 1 has a 0 of positive 1. Remember, to find the zeros, you set it equal to 0. So like this one, negative x plus 1, that one has a 0. If we were to solve it for x, we would get x equals 1. So that one has another 0 of just 1. So look through each of those factors, see what their zeros are. I do want to point out this p of x one here. So if we wanted to know what its zeros are, that means we set it equal to 0 and we solve. Most of the time when they're already factors, you just take the opposite of the factor. This one's not totally factored all the way, so we can't just take an opposite. There's a square in there, so we really need to separate it out, set it equal to 0. If we were to solve this, we get x squared equals negative 1. Take a square root. So remember, you find zeros by setting the factors equal to 0 and solving. When you take a square root of a negative, remember that means the I term comes out. So it becomes x square root of 1, which square root of 1 is 1. We get plus or minus I. So remember, whenever you take a square root, you get a positive or a negative, which means when you have those imaginary roots, they come in pairs. We talked about that a little bit before. So the zeros, that p of x, the x squared plus 1, is really plus or minus I. They are imaginary. So what you're doing, and this was just a little bit to help you think about those factors ahead of time. You're going through, and the goal is to create new functions. So like for A, it says we want to create a cubic function. So to create a cubic function, that means we need to end up with an x cubed. So like x times x would give us x cubed. So if we multiplied 3 linear factors together, we get an x cubed. Or x times x squared is x cubed. So we can multiply a linear factor by a quadratic factor. So like this first one for A, it says we need to have 2 imaginary zeros and a real 0. Well, out of all of the ones in the bank, the only one that gives us those imaginary zeros is this p of x. So in order to create a cubic with that, it would need to have a factor of x squared plus 1. And we also want a real 0. We already have x squared, so we can only have one more x in there for it to still be cubic. So we could pick any of these factors. So you could pick f of x, g of x, h of x, or this other f of x. It doesn't matter. I can just put an x out there. And that would be a function, a cubic function, because the x times the x squared makes x cubed, that has one real 0 of 0, and 2 imaginary zeros. So your goal is to piece together these pieces from the bank to make these different types of functions. So something with 3 imaginary zeros, something with a y-intercept of 0, -1, something with a 0 of 1, but with a multiplicity of 3, so the same factor repeated 3 times. 3 distinct 0 means 3 unique, so 3 different zeros, whereas multiplicity of 3 means it should be repeated. So you guys are going to play with that. Use Desmos to help you out. Like graph all these functions on Desmos and try putting different ones together. It's really meant to be an exploratory, play with it type ordeal. So we're going to go through that, and then you'll hopefully be able to come up with some conclusions. So like, how many combinations can you have? And then you're going to read. There's a couple of work for you guys to read. What Emily has to say. She can make 1, 0, 1, 2, or 3 imaginary zeros. Is that possible? This one, we have this one function of 3 zeros, 3, 1, and -4. Augie, Catherine, and Chili made 3 different versions. This Desmograph, Augie's version, is already done for you, A of x. What was her name? Catherine's version is K of x. Chili's version is C of x. So this is just, again, a way for you to play with these functions. It's the ones they have in here using Desmos. So there will be a Google form for you to kind of put your ideas in for these answers. I want you guys to really do that activity and think about them. Once you get through there, the rest of this will be pretty similar. So 4-2 gives you time to think about the different type of combinations you could have for a quartic function. So quartic, remember, is x to the 4th power, meaning in order to get to that, we have to multiply 4 x's together. So you could do that in the sense of 4 linear factors, x times x times x times x. We could have, say, we combine those. We could have 2 linears and a quadratic. What if we combined those? We could have a quadratic and a quadratic. Or we could have, combine 3 at once, a linear and a cubic. So think about that for a second, just those different factors, because then you'll be looking at the same idea in 4-3. So 4-2, really that first question is all we're thinking about, what different types. The rest of 4-2 we're not going to worry about today. It goes in kind of a different direction that we don't need. So after you look at that question, you can skip ahead to 261 on 4-3, which is building the quartic function. So again, look at those factors, analyze them first, see what you think about them, which are linear, which are quadratic and cubic, what are their zeros. And then the same deal, but for these, for 4-3, just worry about A, B, and E. So how can you do 2 imaginaries and a double, 4 distinct, and a multiplicity? 2 and 3 and 4-3 are really a bit more of a stretch, just to really ask a lot of questions about one function, and it brings a lot of our old ideas from lessons 1-3 back. So you'll work through each of those, and then we'll close out with another always, sometimes, or never. Talk the talk, just to try and make some of those comparisons, and then just thinking about how we can make a degree 5. We will not go through and do a bunch of degree 5s because those just get pretty complicated from there. So there will be a Google form up for you for these pieces. I think this lesson will probably take you the bulk of the day today. So there are obviously Mathias you can work on. You will have time Thursday to work on some Friday to work on Samathia as well. Today is Wednesday. So I believe at the beginning of the video I said Happy Tuesday, Happy Wednesday. I forgot about the 3-day weekend as I was making this. So your big goal for today is working through this lesson, making sense of these, and working on that Google form. So again, I will have answers. A lot of the Google form will be check boxes and multiple choice. So that way you can get some feedback to see how you're doing on those answers. Again, they do not have to be perfect. You do not have to do the Google form a million times unless you want to. You absolutely can redo it over and over. But what I really hope you can do is go back, look at the answers, reflect on them, and see what that means so you can use those mistakes to help your learning. So let me know what questions you have. As always, I am available on Zoom for the full time today. Happy to help you through this lesson. Friday will be a catch-up day to make sure we understand all the skills from lessons 1-4, catching up with some of that Mathia. So hopefully this is starting to bring full circle, kind of bringing some of these points home. So otherwise, have a wonderful day, guys. Hopefully I'll see you. If not, like I said, have a good day and happy learning. See you guys.